So in this video, we are going to see what is the coding aspect of decision tree classifier. So if you want to go through the concept of what are the things involved behind the scenes theoretically, there's a link below in the description of my blog where I have written it very clearly. What is entropy, what is information grain, what are leaf nodes, what are decision nodes, what is the root node, and how the splitting is happening. And this is a very common interview questions they ask, that how how could you build a decision tree in machine learning interview. So you can go and have a look on that. But as far as coding part is concerned, watch this video and from start to bottom to get an understanding of how you could use that theoretical knowledge to apply it on this platform to get the desired output. So the first thing that we are going to do, usual, we are going to get the data set. You will get the link of this data set in the description below. I'll put the link and you can access it there. So here in this data set, as you could see, these are the gender, age, estimated salary, purchase. So here what I'm going to do is I'm going to find out based on these 4 characters, like whether I could purchase the product, whether the person who could, the concerned person is could have purchased or not. So it's a yes or no, have purchased, have not purchased. So the first thing as we move ahead is we are going to check if anything is null or not. So let me just load this set first and I'll just check if anything is null is not. So here nothing is null or none, not a number. But in some cases you will get situations where you will find that some of the values are null, not a number, and there could be a value which is a little bit, not little bit, a lot different from other numbers, which act as an outlier, which distorts the normalization of the data set. So these kind of situations you will face. I have a blog about all of how to handle all of this, how to handle missing values, how to find out outliers, how to handle outliers. So do remember to check my blog so that you could have an idea of how to handle these kind of things, which is not in this case, but in most of the data set that you will come across, you will have to handle that. So here we do not have any not a number situation. So the next step that we'll do is we'll go for the encoding. As we know, in case of numerical data, we will standardize that, which we will do after the splitting. But in case of the categorical data, we have to convert that into a numerical ones, because in the previous video I have clearly spoken that what are the types of the data types we have in data science, and what are the categorical values, what are the nominal values, what are the ordinal values. So you can check out that video, and there is also a lot of resources available on my blog and on internet which you can find it out. So here the first thing what we'll do is we'll find out any of the categorical values, then we'll encode it. So usually in other kind of projects like real estate projects and all of that, you will find a lot of columns, categorical columns. So in that case we will use one hot encoding, label encoding. I have spoken about all of this in the in the previous video that I uploaded. I'll also put a link of that video, just check out that. But here, since we have a minimalistic number of columns, so we will use manual encoding. So here I am encoding male as 0 and female as 1, storing it in the column. So here I am getting 0011, which was previously male male, female female, and then male. Now the next step is, after having that done, now the next step is separate the xy value. Xy value is the value which is the target, which is the deciding values, and then y is the target value. Target value which we want to predict, and the deciding factors which will help us to predict the target value. So anything except the purchase target is deciding factors, and anything that is purchase, the value anything whose values comes under the purchase column is a target value. That's what we are going to predict. So after deciding what are the x factors and y factors, because we want to give these factors when we are trend test splitting it, that is a function we will get from sklearn. That is a very popular and a very essential module in for data science in Python. So we'll pass the xy value to that, and test size and random state. So these are some of the parameters that we want to give test size, how much percent we want it as test and how much percent we want is that train size. So train size is the model will train on that data set, and test set is the unseen set for the model on which we will predict. So after passing these values, we'll have a set of train test y test. Okay, x is not defined. Yeah. Now if you want to take a look at how x test becomes looks, it looks like this. Similarly, we could also see x y test, and yeah, the link of this GitHub repository is also in the in the section, in the coding section below, the description below. So just remember to check out in case you want to access the code for your own practice. But I would say you go through the blog, and then you I'm giving enough stagnancy to the screen so that you could take a look at that and type along with me, so that you will also stop the video, type along, and then start the video, and then type, and then see the results for yourself. So after that, so we have done our data, our missing value, our data processing, and then we have train split that we have find out the xy, then we have train split that. Now comes the numerical part. We want to standardize the part, because if we don't standardize the part, there will be a distribution uh, error, like there will not be normalcy in the data set. So for that we'll use standard scalar, instantiate and standard scalar, train and test, pass the train and test data set to that, and get the and transform it using the transform function, and get the scaled test and train value, which we will be using further in our experiment. So this is the x test value. As you could see, I could also show you the x trend value. That is, these are all scientific numbers that are coming. So this is the scalar, standardized scalar value, and after that we will move to the next step. So the next step is something like this. We will import all the required libraries for the model building. Here actually what happens, we will get the real taste of what we are going to do in this, what we have studied in that, in the theoretical section in my blog, and what we are applying it over here. Here actually comes the real scenario. So first of all, we'll import from sklearn the decision tree classifier and instantiate that, and fit that x train and y train that we got from the train test split into this, and train the model. If you are using this fit function, meaning we are training the model. Now the model is learning about the data set. Now the model is learning if the person is male, if the person estimated salary is something, if the person age is something, then he has purchased. Now based on the pattern, the model will have all of this pattern inside that. So based on that pattern, it will decide on the test value, test case. Okay, so we have instantiated and means fit the model to the data set, and then we'll predict on the uh, on the training set and the testing set. We'll predict on the training set and the testing set. So CLF will use a function predict and pass the extra and extra test value to get the xy train predictor and xy test predictor. So I am showing you currently the xy x test predictor. I could also show you the x train predictor. So this is the x train predictor, that one is the x train predictor. These are all numpy arrows. So the categorical values are being converted to binary values so that the model would be able to understand. Now we'll get into the accuracy score. So before we, for the pruning part, we will have to look, we are doing post pruning method. That means we have to let the tree grow before we prune it. So that is the thing what we are doing. We have let the tree grow on its own. We will see the tree structure after this, after getting this course. So we have let it grow. So now we will check the accuracy score. So here you get on the test value it is 0.9, on the train value. And the train value it is high because obviously it has learned a lot about this. So it would have a lot of knowledge about this. But the question is, it should have a good prediction based on what it learned in the training value when it is applied on the testing value. So it should have a good clarity from for that. So here it is 0.9. Now here actually if you could see that it is showing 0.9, that means 90%, you could also think that it is a good accuracy, but it is not. Anything that is high and anything that is low, that is not accurate. So here there is a problem called as overfitting problem. As you could see, I have written the difference between that is high. So in that case, what will happen is it will get overfitted because there is a huge number, there is a huge like gap between the accuracy score, and then the accuracy scores are also very high. So here there is a overfitting problem. So this is the problem we are going to alleviate by using the pruning technique. So let's move ahead. I'll just show you this tree. This will take some time to come up. Yes, it came up. So this is the unpruned tree. So this is the tree. If we are unpruning it, it will show up like that. So it has got leaf nodes, it has got decision nodes, root nodes. So the first one is the root node. It is getting branched based on the entropy. So the entropy is like the degree of if you have gone through my blog, you would already know that it is the degree of disorderness. And then if the degree of disorderness is more, then it is likely to split. If it is less, then it will likely to stop split. So this is the unblend. You can read more on in my blog, but this is for now. This is the unpruned tree. Now the next thing is that we are going to prune it. So since we are getting overfitting problem and we are let the tree grow on its own, so we will try to prune it. So the first thing what we are going to do is, on the instance of CLF, we'll apply cost complexity pruning path method. That is one technique for pruning, and pass the external white trend value and get the path. Now this path has two things: CC alphas, CCP alphas, and impurities. So CCP alpha, these are the hypertuning parameters you can pass to the decision tree classifier to optimize its performance. The model building, the model learning part, and then impurities. So basically we will make use of this CCP alphas. So this array that we are getting, we will make use of this to optimize the model performance. So first of all, what we'll do is we'll loop through the, here what I'm doing is I'm looping through the CCP alphas. I'm creating another instance of decision classifier tree, and I'm hyper tuning the CCP alpha and passing the CCP alphas I got from this array like 0.022. So CCP alpha is 0.022 for this particular instance, and then we will do that like this for all the instance, and then we'll fit this with the external white trend value after creating the instance, and then we are appending the model to CLFs. Now we have a bunch of models based on the CCP alpha values. So we have a bunch of model. Now the next step is we have to decide what is our decision tree, what is the last node of the decision tree, and what is the decision tree look like. So here you could get the information. There is some mathematical calculations that you need to do, like the last the last node of this one, the model, you will get -1, so you could access all the last instance of this array and this model. So that is the last parameter you will get. Now we have all the model with us. We have passed all the alpha values. We have created the decision tree classifier. We have passed the trained and extrained and white trained value. We have the array of models based on the alpha factors. Now what we'll do here is the comprehensive array list comprehension method that they have done is I'm looping through the CLF's values, getting the instance of CLF value as CLF, and then I am putting a score of this extrain and putting a score on this CLF value. First of all, getting the instance of the CLFs from the CLFs as CLF and putting a score function on that and passing the external white train function to it. So likewise, what we'll do the same thing for the test part also. We did the same for the train part, and we will do the same for the test part also. Okay, after having that done, we will have our test scores and then train scores. So we applied this list comprehension and get the scores, and then we have test and the train scores. Now we will plot a graph of this test and then train scores. So this is the plot, this is a graph that we plot on the test and then train scores. As we could see, we would have to now the next step is we are going to plot this training scores and then testing scores that we got, and we plotted it. Now here, in that case, we got an array of alpha characters and you put it and we find out what is the accuracy score. Here we'll try to visualize the same thing, and then we'll try to find out a merger point of the test set and then the train set, and that point will be at the low variance and then the low bias point, and we can use the alpha corresponding to that part as an alpha parameter to train our model. So here things might sound a little bit of confusing when I say low variance and then low bias, but since this is data science, it is going to be very fast and there will be a lot of unknown parameters that we will come across. So we need to understand all of these things. We will cover this eventually, but right now you just understand that any point that has the points that shows a merger between the test and then the train data is a low bias point and low variance point. And here we see that there is a very less merger point of the both the data sets. So I have picked the value as 0.05. 0.05 as this is the merger value, because this is like one value could be this. You could put this value. I have used 0.05 to see how things will happen when we go to 0.05. So this is the pruned tree that we are going to concentrate upon after the pruning. So let me just revise it for your clarity. So first case we use this cost complexity pruning path. We got all the alpha values, we applied it, we get the test and training scores, and then these are all the test and training scores. Then out of the scores that we got, we have to find one alpha values that is apt for our uses. So we have got the array of that one. Here we will use the apt value out of the array, out of the results what we got in the array. So I picked 0.05, and this is the pruned tree, as you could see. Now we will make use of this part of the tree to make the decision, not the entire tree, because we have pruned, we have stopped it over here, like from the leaf node to the decision, from the leaf node, from the decision node to the leaf node, we have pruned it and we want to work on this part only. So now after I pick the alpha factor as 0.05, I will run the test score and then the train score. So accuracy score is there. You will have to pass the actual train score and then the predicted train score. Now the predicted train score is the tree classifier instance dot access the predict function and then pass the extrain value. Same thing for the y for the testing part also. So here you will get the Y train is the actual training data point, and C, and this part is the predicted data point, and this is the uh, accuracy scores 90, 95. Now in the previous case, if you remember, we got for the test score 90, and uh, for the training score we got 1. So the gap between that has decreased, and they are now nearing towards each other. That means the uh, fitting problem has solved to a lot of extent. So that is the first thing. Now we could also use another way to visualize that. We will take all the alphas, array of alphas that we got, we will feed that to the decision classifier tree, and we will create the model out of that, get the predict data and get the predict test data and the train data. As I told you that the instance, and then we'll apply the predict function and then pass the x and train value to get the predicted value. Now for the accuracy, we will have the accuracy score matrix from the sklearn and pass the Y train, the actual data point and the predicted data point. We will repeat the same for the training and the tracing part also, and put it in separate array. Now we will plot this array to understand how things are working. So if I plot this one, you could see the similar kind of trains of this one. So here we are plotting the scores, right? Here we are plotting the scores, but here we are plotting the accuracy, direct accuracy scores. So here it is also showing that there is a less overlapping factor uh, between the two test and then training set. So here I took it as 0.1. That I previously I took it as 0. I experimented it with 0.05. Now I get 0.1. Now if it is 0.1, this is the prune T that I got. Okay, it looks almost similar to like to 0.05. There is almost no difference. And if I get this accuracy score, okay, I haven't, let me just run this. So I ran this one, and then the accuracy score looks like this. So it is 6272. Okay, so as I was experimenting on this, so as we thought that 0.05 is the most important, is the most accurate measurement that we are getting. So we will go with that value and feed and the training model out of this experiment to find out that 0.05 is the optimal value for the CC alpha. So we'll put that value, we'll train the model on that value and get desirable results. So this is how you approach the pruning techniques and the decision tree classifiers for the classification problems. Remember, I have also mentioned it in the previous video for the classifiers. If there is a yes or no things, if there is a yes or no thing, then it is a classifier. And if you want to predict how much or how often, then you will go for regression tree, decision tree. You will also get the entire information about this on in my blog. So do remember to check that out and watch this video and code along, so that you will get fullest of what I am giving right now. So this is all about the pruning approach to pruning and decision tree classifier. Hope you enjoyed it. Just try to, I understand that in data science everything is so overwhelming. A lot of things that is not known comes out of it, all out of the blue. Even I have also felt that, I am also feeling that. So basically what we have to do is we have to go with the flow, and we have to take things as it comes to us and digest it and use it. So this would be my suggestion. So I hope this helps. I will come up with a lot of videos like this for your help. Hopefully you liked it. If you like it, please don't forget to like, comment, share, and give your valuable queries, give your valuable comments. Or if you have any queries, you could also put it in the comment section. I will make sure I'll just comment, I'll respond to this to your queries. So yeah, that's it for now. Meet you in the next episode. Thank you.